listening, please let me know. So this lecture we have like 20 slides. Okay. Okay. So this is more like, okay, what type of recordings, okay, that we are going to apply on the biopotential. So we have two, okay, actually ENG, electroneurogram, okay, and also our EMG, okay. So electroneurogram, I think is a bit new for you, I think, because we are always exposed to EEG, okay, electroencephalogram, okay. Actually, EEG is a part of ENG, it's a part of ENG. So jangan takut lah, don't be blank, okay, don't be worry, okay. We just include everything, okay, we just include everything, okay. So EEG is a part of ENG. Okay. So why, what, why, and so on lah. Okay. Okay. ENG, okay, is a method used to visualize directly recorded electrical activity of neurons in CNS, central nervous system, brain, spinal cord, or the peripheral nervous system. Okay. So we use the acronym ENG. It's easier, okay, for us to understand. Okay. Electroneurogram is quite lengthy. Okay. So we are interested to know what is the what is the electrical activities that happens in our neurons, okay, in our nervous system, brain, what happens there, and so on. So from there we know that, okay, is our brain or our nerves, okay, works works normally or not, okay. So because we have understand the fundamental of it, okay, we have understand that our nervous system, okay, works using electrical potential and so on. So it is an advantage for us, okay, to understand what is happening in our body, okay. You know whether everything is fine or everything or there should be something wrong, okay. Okay, so ENG, okay, is similar to EMG, okay. So but the later, okay, the EMG is used to visualize muscular activity, okay. So the principle is, okay, we observe, okay, we observe the potential, okay, of the nerves, okay. For MMG, we observe the potential, okay, the potential that happens in the muscle. Okay, that's why here is the thing that I want to highlight to you previously. Okay, 100 people. I hope 110, 110 comes in, 111, okay, comes in, okay. EEG, okay, is a particular type of electroneurogram in which several electrodes are placed around the head and the general activity of the brain is recorded, okay, without having very high resolution to distinguish between the activity of different groups of neurons. Okay, so as usual, people when first time they want to record it, okay, they want to see whether, okay, few electrodes is enough, okay, should we have this much of electrode. So they have like a system, okay, like how many electrodes they should put, okay, where is it, and so on. It's similar to what we have for ECG, okay, for ECG. So okay, we are trying, okay, not to have a very high resolution, okay, and not to distinguish the activity of different group of the neurons. So this is the what, okay, the why. So the setup, okay, the setup, okay, it doesn't have to have a high resolution, okay. Although all this statement is true, okay, our that's our EEG is, I think, like 180K, I think, in our lab. 180K that time lah. This time I think it's much more lah. Okay. It's 180K, I think. Okay. It was that much. I'm not sure how many of you that will do EEG, okay, for your FYP, okay, but soon I think at least 4 or 5 of you will I think more lah, okay, 5, 6, 7 of you will do study on the EEG, okay. Okay, so looking at this, what are the difference? The one, okay, the left one, you just wear your cap, okay, full of electrodes and so on. Okay, the other one is scary. Okay, you have to, okay, open your skull. Okay, and then have a direct measurement of it. Okay, so one is more invasive. Okay, one is invasive. One is non-invasive. Although, yeah, the invasive one, not the invasive one is should be more precise than the non-invasive, but yeah, people are trying our best, okay, to make sure that to avoid, unless if it is very critical, unless it's very, very critical, okay, to have a measurement of it, okay. Okay, so we are not going to go for apa nama ni, for the EEG, okay, looking at the direct invasive EEG like that, okay. We are trying to understand the fundamental, okay, the basic of it, the basic of it. So, okay, I know some of us, okay, may wonder, okay, all the syllabus that we learn, okay, especially after this when you go to bioinstrumentation 2, okay, and it is in your like final year, and the technology, okay, sometimes maybe like 40 years back, 30 years back, and so on. I know the demand from the job market, okay, the employer, they want you to know everything. But as you know that, okay, our syllabus, okay, our system, okay, we cannot jump everything. Okay, that's why we still have maths. We still have maths. We still have some like what I call the electrical circuits. You have to learn what we call yeah, like anatomy and physiology. Okay, there's a few fundamental courses. Okay, maybe analog electronics and so on. Okay. And then, okay, when you go, okay, this is like your nearly to final years, you learn something that is like 30 years, 40 years back, okay. I know some of the technology taught to you maybe just around, okay, 10 to 20 years, okay, but we can say that when you reach your final year, okay, the thing that you learn is like, okay, it's we can say it's in the bracket obsolete, okay, but the problem is that, okay, how you can move forward in your field. Okay, so if you learn something, if you jump, okay, whatever the technology that we have here, okay, let's say if you don't know what is the basic, okay, of ECG, the basic of EMG, so on, okay, for this course, you don't know what actually happened. Like for a car lah, for a car, okay, you only know that, okay, it starts by just pushing a button, but you don't know the mechanism, okay, how the piston works and so on, okay, the basic of it. So here we build your basic first. That's why sometimes, okay, people may question, okay, the degree, those from degree, they are a bit slow compared to the diploma or from the technology, okay, courses, engineering, okay, you are a bit back, okay, but there's the reason why, okay, we withdraw a bit, okay, we move backward a bit, okay, for you to move forward faster. Okay, you need to have some fundamental knowledge, okay, for you to analyze, and then you can spring, you can lompat lah kan, you can leap further fast. Okay, if you don't understand the basic, and how can you solve problems? Because okay, you have to understand the difference between you, okay, the technicians and also the technologies, okay. And technology also ada dua, there's two, the engineering technologies and also technologies. Okay, I don't want to discuss it now, okay, because we have quiz, okay. But you are the guy, okay, that will solve the problem. That's the thing. Apa jadi pun you have to remember, okay, in the industry, okay, at work, okay, you are the one that will solve the problem. Doesn't matter whether you work in JKR, you work in the vendor, okay, with the vendor, okay, or you are working with for sales or something, okay, you are the one that is going to solve the problem. So we build your basic here in this course, okay. So that's why, okay, don't be when you go to apa nama ni, to your latihan industry, and suddenly you feel that alamak, I don't know how to touch this, not touch lah, touch everybody can touch, to use the spanner, how to use the screwdriver and so on, you feel that you are second class, don't ever feel like that, okay. Okay, you are there to be exposed of what the problem, okay, but later on, okay, you are going to solve the problem. Okay, maybe during the LI, the intra, okay, they won't allow you to solve the problem lah, okay. But mind you, okay, you have to, okay, play two roles there, okay. One as a intra student, okay, LI students that just what I call follow whatever the supervisor asks you to do. Another one is to expose yourself, expose yourself to the real work that you're going to do in the future. So I hope that, okay, so I hope that you understand your role lah as an engineer, okay. So I finish this particular note first, okay. So what happened? Okay, lateral neurogram is usually obtained by placing an electrode in the neural tissue. So okay, this is like more like, okay, on the apa nama invasive one lah kan, okay. But because, okay, obtained by placing an electrode, okay, to the neural tissue or adjacent, okay, we can say that lah, okay. So the most important thing is that, okay, the electrical activity generated by neuron is recorded by the electrode, okay, and transmitted to an acquisition system, which usually allows to visualize the activity of the neuron. So these are the important thing that you have to understand, okay. Yes, and okay, in the neuron, what happened there? Electrical activity, okay. What do you have? Okay, electrode, okay. What does this electrode do? Record lah, okay. Record, okay, what the activity that is happening, okay. You transmitted it to acquisition system, okay, and then you allow to see what happened in the what are the activity of the neuron. Okay, so if you understand this, okay, you pushing kat mana, anything happen, okay, so you change the name, okay, whatever done and so on, okay. In the end of the day, you understand you can see, okay, you can understand the activity of the neuron, okay. For instance, okay, what type of electrode that you can use, okay, maybe it is a suction cup electrode, okay, transmitted, okay, maybe maybe wireless, non-wireless, okay, or okay, you want to see in the form of graph, okay, maybe in terms of maybe in the in numerical means that numbers, okay, but you understand it, okay. So so as an engineer, okay, if let's say one day, okay, you want to improve the system, or maybe you are in the not critical lah, we can say maybe in the problematic times, problematic times, okay. What are you okay? If you want to see that, okay, if a person, okay, have is paralyzed, okay, maybe maybe you just want to see whether okay is 1 and 0 or something. So if you understand this concept, okay, understand the concept, there's a lot of innovation that you can do, or maybe if not innovation, okay, maybe you can invent, okay, or develop a chip system that can help many people. Okay, you can be like okay lah. For I'm not sure about nama sini lah. That you can be EBU for for biomedical engineering lah. Okay. Okay, so this is the basic of it lah. Okay, after this we go for equation and so on. Okay, conduction velocity in a peripheral nerve can be measured, okay, by stimulating a motor nerve. Okay. A motor nerve at the 2 points known as at a known distance, okay, apart along its course. Okay, we cannot take the whole thing lah because the muscle nerve is long. Okay, like for instance, in your if you want to measure, okay, this, okay, if you want to measure this along the legs or something, okay, that will be quite long. Okay, so we try to look at the peripheral nerve lah, okay, instead of looking at the CNS, the cerebral central nervous system. Okay, so T of 2, okay, stimulating a motor nerve at 2 points, okay, here D at the known distant part apart along its course, okay. So you have the reference, okay, and so on. Okay. After this, we have an equation of this, okay. But remember, this diagram is important, okay. So you have this D, the distance, okay, because the formula, okay, really has is represented by this diagram, okay. Okay. Okay, and then after that, okay, these are done through subtraction, okay, tolak, subtraction of shorter from longer latency. Okay, this is shorter, this is longer, which gives the conduction time. Okay, we have T here, okay, this is the V, okay, okay. So you tolak, you subtract the L2 from the L, okay, from the L1, okay. After that, you can get the equation. Using the known distance, the conduction velocity can be obtained. That's why you have the V just now. Okay. We have V. Okay. You have to mention the V. Okay. Okay. V is the velocity. Distance D is the distance between electrodes. Okay. L1 is time of longer latency. L2 is the time of shorter latency. So you have it here lah. Okay. Okay. So you can measure these signals, okay, either using the concentric, needle electrode, or surface electrodes. That's like I told you, okay. How accurate, okay, if you how accurate, okay, how precise of the measurement that you need, okay, and then maybe in terms of is it comfortable or not for the patients, okay. But like I told you, the statement okay, this statement is a very strong and powerful statement, okay. So electrode means that, okay, here you can imagine lah whether you can use the needle electrode, okay, or surface electrode. So from there you can okay, make a lot of maybe I just ask, okay, maybe for in the examination I can just by using that statement I can ask you to design, okay, ENG, okay, energy systems for many things, okay, maybe just for your finger, okay, maybe to measure, okay, those diabetic patient who may have nerve problem, nerve system problems, okay, maybe on the paralyzed person. There's a lot of things to ask, okay. just okay, pushing, just on those statements on that particular paragraph. There's a lot of things that can be asked. So please be creative, because you are in the final semester of your third year. Okay, so you cannot just think satu lapis, one layer. You have to be creative. You have to see this from many angles. Okay. Okay. Nerve field potentials. Okay, measurable by stimulating motor and sensory nerve. Okay, which results in field potential for both active fibers. Okay. Eliciting neural field potential from purely sensory or motor nerves. So, okay, we know that the both of these nerves. Okay, we know this nerve have a field potential. So, with that, okay, we can measure. That. Okay. Okay, so application of ENG includes, okay, that I told you just now. This is more basic lah. Okay, just now I told you about the application. Okay, but you can but then this gives you some idea lah. What you can go further from this. Okay, okay. So you have the sensory nerve field potentials. Okay, motor nerve conduction velocity, reflexively evoked field potential. So those three lah. Those three that you can study. Okay, and then the parameters. Okay, conduction velocity and latency. Just now we have the V, okay, V, and then the latency. Okay, the timing. Okay, characteristic of field potentials evoked by stimulated nerve. Okay, so that's why if you understand this, okay, and also the characteristic, okay, because all in this world, okay, we have patterns. Okay, we have patterns. We have patterns like we know that. Okay, like, I know it's difficult if you live in a temperate zone, but let's say like in like tropical country, definitely, okay, around 7 something, the sun will go up, will rise, okay, in the morning, okay, but in 7 something in the evening, okay, the sun will go down, okay. You can see there's a pattern. So this is also, okay, I'm giving you a bigger picture lah, a bigger example lah. But even in our body also we have patterns, okay. So it's easy for us to see the characteristic, okay, and it's easy for us to relate it with something. Like for instance, that's why we have ECG. ECG symbol. Okay, since like even during my time, okay, when I was a biomedical engineering student, okay, our logo, our symbol is always the ECG. Yeah, the ECG signals. Okay, there's a pattern of that. Okay, of that. So how about ENG? So ENG also have the characteristics. Okay. Okay, let's go to slide number 12. Okay, for the sensory nerve field potentials, okay, we measure by applying stimulus on the sensory nerve. Okay. So you have, okay, a cuff there. Okay, you put your electrode. Okay, you put electrode. Okay, so this is the difference lah between, okay, your source from here and then your source here. Okay. So you can see there's a peak. There's a peak there. Okay. Okay. Ring stimulating electrodes applied to the fingers. Okay. Oh, there's the fingers. Oh, you have, okay. We have a finger. Okay. Okay. Applied to the fingers. Known distance allow computation of conduction velocity of sensory nerve. Okay. Okay. For ulnar nerve, okay, potential can be recorded as high as armpit. So it can be, okay, can be quite high. Okay. For median nerve, potential can be recorded above the elbow. So this is how, okay, how you want to compute it. Okay, let's go to the next page. Okay, long simulation pass result in muscle construction. Okay, limb movement. Okay, under the artifact. So these are the things that, okay, let's say you need to do the experiments, okay, for okay long time, okay. So you have to consider this, okay. The muscle may contract, okay, because you are going to stimulate it, okay. And then after that you have a limb movement. When you have limb movement, okay, definitely your electrode, okay, will be affected. Then there will be undesired artifacts. So all, okay. So these are the problems. You can okay. I think I have given you this earlier. Okay, for that sekarang 104. Okay, we have 104. Let me pass the attendance again. Okay, okay. Please fill in your attendance. Okay. So okay. So how you are going to overcome this? Okay, you should, okay, make the limb comfortable. Okay, the patient in the relaxed posture, and make sure that the stimulus is short. To make sure that short but intense. Okay, so it will prevent long stimulation. Long stimulation to avoid all this all three from happening. Okay. Okay, what are the good one? Okay, so you need to benchmark. Anything you need to benchmark, anything you need to have a standard. Okay, what are your desirable stimulus? Okay, 100 volt, okay, amplitude, duration is about the 100 and 300 microsecond. So short lah. Okay, so you can exercise large rapidly conducting sensory nerve fibers. Okay, and we don't want to elicit pain fibers and surrounding muscle. This is the reason why lah. Okay, and then we can diagnose. Okay, the peripheral again peripheral is your nerve. Okay, your nerve, your kaki, leg, tangan, so on. So this is a peripheral. Peripheral is tepi. Jangan ingat peri-peri sauce, Nandos ke apa kan. Okay, peripheral, okay, something to do at the side. At the side. It's not at the center. Center we go to like for instance, like for brain, brain EEG lah. Okay. Okay. So now we go to motor nerve conduction. Okay. So this is the formation. Okay. Conduction and velocity of motor nerves can be measured as follow. Okay. This one of example. Okay. The nerve of the left leg. Okay. Okay, and then we can diagnose the motor neuron abnormality. Okay. Recording of the second potential after the initial response. Okay, okay, this is for reflexly potential. Okay, recording of the second potential after the initial response when the peripheral nerve is stimulated. As the neural stimulus site is brought closer to the muscle, the latency of the first response decreases, while the latency of the second response, okay, is increased. Okay, this is if you refer to the past year's question of the quiz. I'm not sure some of you have it or not, but yeah. Okay, this question have been asked in the quiz, but because we haven't finished yet, so I just cover the previous lecture notes. Okay, so don't worry lah. This question, any questions kan? Any questions from this chapter tak keluar lah. Okay, it doesn't come out for our quiz. Okay, we have another like 3 more lecture notes. Okay. Okay. So indicates that the stimulus travels to the CNS approximately for some distance before traveling distally in the opposite direction. Okay, proximal. I hope you still remember about the terms, terms in anatomy. Proximal dekat, okay, is near. Okay, distal is far. Okay, travel. Okay, stimulus travels to the CNS. Okay, near. Okay, near for some distance, okay, before traveling distal, okay, before traveling away in the opposite direction. So you need, if you can remember, please jot it down. Okay, this suggests that the signal, okay, travels along the sensory nerve to as far as the spinal cord to elicit a spinal reflex. Okay, so it is an electrical homolog. Okay, it is what I call say in Malay with kias. You can say that it is similar to a simple knee-jerk response. So that's why I told you. Okay, if like say an exam question, I can ask, okay, about maybe how to knee-jerk. Macam okay, it's like when you're okay. I hope you still remember. I'm not sure myself during Form 5, Form 5 for biology. We learn about okay the response, this autonomous response, everything. You hit the knee and then it jerk, okay. The lantern, bukan lantern lah. It moves, okay. It moves back. So maybe okay. Occasion can come out, okay, because just based on the statement that I emphasized just now about okay about what are you going to record it using what, okay, why is the reason and so on. So okay, just based on that, okay, many questions can come out. Okay, we have 20 minutes. Okay, before this. Okay, one example, okay, stimulate popliteal nerve and record at triceps, okay, triceps shoulders. Okay, so this is the characteristic, okay, we said the M and H here, we have the P, okay. So the recording is for like 50 milliseconds, okay, and this is somewhere like 2 millivolts, the size, okay. Okay, so it is a low intensity stimulus, only high amplitude H wave observable. Okay, medium intensity stimulus, both M and H wave of moderate amplitude can be seen. High intensity stimulus, only high amplitude M wave observable. So, yeah. Okay. So I told you, if you can have the notes, okay, and then jot it down here, okay, jot it down here. Okay, you have your laptop, okay, print out your. I know during your study time, okay, there's a lot of papers that you have to use, okay, print it out, okay, and then after that, okay, please jot down. Okay, so never let your laptop become clever. Means that okay, I know some of us we just download it. Okay, when we want to use it for, we want to read it. During exam, for exam, then we start to open open the notes. We start to flip the notes. So but I hope from for now, okay, at least you have seen it. Tengok lah, at least you have tengok already. You have seen the notes. So you know, okay, this is which nodes, okay, which you can combine with the figures, okay. Okay, that's it. Okay. So okay, we have finished the lecture. Okay. So we have okay, how many of you? 103, 104. Okay. So let's see now. Okay, we'll try to. Okay, we will start at 4. Okay. Let me upload first lah. Upload first the. Okay, let me finish apa nama ni? Recording. Okay. Terima kasih semua. Okay, sekejap.